power in a piston engine aircraft, and how does that work? What are buses? How does the alternator work? Volts versus amps, things like that. So we're just going to do a little segment and talk about the fundamentals of how these aircraft work, because that's going to then take us to what we're doing in our build. Hey everybody, welcome back to today's segment, and we got a very special segment today. We're here at Banyan Air Service in one of the many avionics hangars they have. And today we have Jorge, who's the chief engineer for Banyan, and thank you so much for sharing this day with us.
Thank you for having me, Ryan.
And so here at Banyan and Jorge, they've been helping us a little bit with our build. And you can go look at the Cub Crafters build and all the stuff we're doing. A very special build for our camping project. Has to do with some very special lithium batteries and stuff. So they've been guiding us a little bit. But we're going to talk today on a couple of topics. One, we're going to get to our build in a minute. I think the most important thing we want to tell you right now first is this is not any kind of official training or education. What you do in your aircraft, you got to get your own professionals and stuff. But we just wanted to share some information with you and talk about why we're doing what we're doing in our build. So Jorge, can we just start with like a general small piston engine aircraft? We've got our alternator, battery, bus, front of the firewall there. Like, can we just kind of talk through like how does that setup work?
It's like your car engine, the same thing. The engine moves the alternator. The alternator generates the voltage, to supply into this in order to charge the battery, and also it's tied to the DC bus of the aircraft.
Okay.
So that's in the DC bus of the aircraft is where all the loads are connected, your lights, your instruments, all your electrical equipment of the aircraft.
Okay, so that we don't confuse turbine versus piston. In piston, we have alternators, and turbine, we have starter generator, right? Because that's a little different technology. The turbine starts, it's a starter, starts the turbine, then we flip the switch and turn that starter into a generator. But in a piston engine aircraft, it's simple. Battery starts.
It's like your car
exactly.
engine.
Now you said something, before I go to buses, you said something about, in our airplane, we're going to have a 40 amp alternator. Mm-hmm. So amps, what do I need to worry about as a small aircraft owner when it comes to my alternator amp?
Basically the rule, in order to keep safe, the supply of the load into the aircraft is do not take more than 40% of your total load of your aircraft. Depends on the type of the aircraft, Every alternator supplies different amps. Depends on the size of the aircraft, of the engine.
So if I have a 40 amp alternator like we do, when you say you don't want to use, rule of thumb is not to use more than 40% of my 40 amps, is that in flight full load, or is that just in flight?
In flight.
So it could be that when I first start the aircraft, you're going to get...
I suggest don't use it during the engine start or takeoff. That's the time when your aircraft needs the more power, landing and takeoff. Actually, also for safety issues. During the cruise fly, you can actually use the whole amperage that you need to.
So this is important because I know in a lot of our aircraft, not this one, but maybe it's the Bonanza or something where we want to use the air conditioner or something. Like when we run that air conditioner, it's taking more load on the more amperage load, which puts more stress on the engine, which lowers the horsepower output. Is that basically why they tell us sometimes to shed certain things before on takeoff or landing?
Yes.
Okay.
Yes, it's for safety issue. In order to keep the load in a certain way that can work in the right way in the aircraft.
Okay.
Do not exceed those levels.
Now, when I'm flying as a pilot, how can I know my load? Basically, my amp meter, right?
Yes. All aircraft is low meter.
Okay, so when it comes to the amps, and I'm a pilot flying, and I see my needle, now obviously I got to look at my POH or the configuration of my aircraft and know what my normal load should be. If my needle's getting close to the red, does that mean that means I'm getting close to the full amount that the alternator could put out? And it's not the full amount of the 40%?
No, it's the full amount of your alternator.
Okay.
The 100%.
So if I know what my normal configured load should be, let's say my needle's whatever in the 3/4. Everybody's meters are going to be a little different. And all of a sudden I see it creeping way up. Then I need to be thinking as a pilot, something is giving me more of a load. Do I have anti-ice running? You know, is a pitot heat running? Or, you know, what's going on that I'm getting an above average load? You know, maybe I need to start thinking about, do I need to shed something that's non-essential and see if that's affecting my load? Because number one, I mean, if it's not in the red and stuff, obviously fly to your next location, land when practical, deal with it. You got to follow your own POH and stuff out there. But at least if I pull a non-essential switch, like a switch that goes back to, you know, maybe my charger here, that it's a non-essential thing, and all of a sudden my load drops a lot. Now at least I've identified, you know, where am I going to talk to my mechanics on, my Avionics, and say, hey guys, I got a problem with this, or when my pitot heat's running, it's way above what it normally is. Yes. Something might be happening.
That's why you have your flight manual operators, because they have like the exact numbers that are your limitations in order to keep maintaining your ammeter or your load indicator, and don't pass and don't overstress your system.
Okay, that was a setup. So then we go to talk about my aircraft and what we did. We're going to come back to that. We also did in this aircraft that's come out of the factory right now, we did a separate dedicated bus. Can you just explain the buses? Because I know we hear in pilots, especially when we get into King Airs and jets or turboprops, you know, it's like triple fed bus or dual bus. Why do we have separate buses in an aircraft? Why is that important?
Yeah, it's important because the distribution, there's an importance also in the distribution of the load in the aircraft. So for safety issues, we gave more importance to certain buses. In order to keep a correct distribution of the loads, we separate the buses in systems. So there are buses, for example, for engine instruments, there's buses for avionics systems, there's buses for essential systems, there's buses for cabin systems. If we keep that buses separate, we have more control to maintain, for example, for the troubleshooting, and we need to cut some buses. And also it's important because, you know, there's a load analysis in the aircraft. This load analysis actually is distribute the buses in the aircraft. It's important for safety issues, it's important for distributions of the load, to keep controlling, no, every section of the load system in the aircraft.
Okay. And like in a single engine, piston engine, it might be that maybe backup G5 might be on one bus and then your main avionics might be on another bus, or so it gives you the ability that if you had to kill one bus, that you don't lose some other important, or vice versa. It's like redundancy. A little less in a piston engine aircraft, but I should say in a single engine aircraft. But then when we get into multi-engine aircraft, it's a whole new world, because now you've got one engine feeding one bus, another engine feeding another bus. So even your avionics might be split up on different buses. So if you lose one engine, at least you still have some primary instruments to fly.
Redundancy in the configuration. In
case you had to shed one whole bus for some reason, you still have other buses that are running other things in the aircraft. Okay, and you can go educate yourself on that, folks. We're just going through the general kind of stuff on that, but you'll see again why we did a dedicated bus for this side of it. So after our bus, then it just basically starts to feed our breakers and our breakers on our panel, right? From that point?
Yeah, the circuit breakers protects the wire are connected to the equipment in order to protect, do not get fire. Circuit breakers is a safety device in order to protect not the equipment, is to protect the wire to not get fire.
Okay, so that's an important point, because I think I know from having some conversations with different people, you know, on Sunday hangar talk and donuts and stuff, people are like, oh, I got to protect this, so you break that. It's not protecting the equipment.
No, it's protecting.
And it's also the reason when in most of your POHs and standard operating procedures is if you got a breaker that popped, the wires got hot for some reason. I mean, it could be a bad breaker, but most of the time the wires got hot for some reason. You reset it once. If it pops again, normally you're not supposed to reset that again, because what that's saying is if you keep doing that, you're taking those wires, now you're at risk at actually making those wires hotter and hotter and hotter. That's going to create a fire. And it's going to create a fire. So that's one of the reasons, everybody, that you don't keep resetting your breakers. After the breakers, obviously, goes to switches and then the equipment.
Yes, basically, after the breakers goes to supply every equipment in the aircraft. Every equipment should be controlled by relays or switches, stuff like that, depends of the equipment.
All right, so just a quick question on like the breakers and the switches. there's not positive and negative coming to all those switches, right? You got negative on the bus, and that's where everything's grounded. But all that coming off is just the positive going through a switch or a breaker, right?
Yes, of course. The breakers only are connected to the positive side of the equipment in this case.
Okay, so I want to switch now and talk about, because once we get to that point in general piston engine aircraft, what we did in the new aircraft here is we had a separate bus put in that's going to drive an accessory switch, and that separate bus has a breaker, a 40 amp breaker switch on it, that then drives wires back to what's going to be our DC to DC charger inverter, basically. And then this inverter is going to charge this lithium, not lithium ion. So what was the advantage of us putting in a separate bus just to drive this?
Like we talked before about the load of the aircraft, the importance to have a control of the load of the aircraft. Keeping in the separate bus is basically separate this equipment from the actually aircraft systems. So for some safety issue, you need to cut it up, isolate the integration of this battery charger that you're going to install in your aircraft. So you're going to have control in order to protect your...
Okay, so the word you said I think is critical, and that's what I want to know is isolate. Because in this build, we've got Starlink going in there. We've got some different chargers in the back for USBs and things. We have all this accessory stuff. So we have a separate little panel of switches that basically from the panel of the aircraft back, we're able to isolate anything there, all that extra accessories. For some reasons. One, as a pilot, I want to know that I can isolate that. If I see not just that there's a problem up in the aircraft, maybe I see that there's a problem behind me. Maybe I see that something's smoking or there's a problem. Boom, I can flip that switch and isolate everything in the back. The second reason is what we just talked about. Maybe the load on the aircraft seems a little high, and this might be pulling too much load. Now we can control these, and we're going to talk about that in a second, but I might be saying, that alternator is really working hard. I don't need this stuff. Maybe I flip off my accessory switch, take that load off the aircraft right now, especially if on the grounds, high altitude in a bush plane like we are, in the mountains, at 9,000 feet, getting ready to take off. I don't want all that load on the engine. So I'm going to isolate and kill all that stuff in the back of the plane, and then gives me all the power I need to get out of that high altitude airstrip. We should say that, this is an experimental aircraft. The Cubcraft is the FX3 we're building. So we are using a Victron controller. Now we use this in our E3 camping, overlanding. This is not FAA level type stuff. This is not aircraft level type stuff, but it works great. We use it all the time. And this DC to DC charger will then, we're going to feed our wires from the accessory switch up front to the end, and then we'll pull our ground off the bus, right? So the bus and after the switch comes to here, correct? Is that how we do it?
Yes.
And then basically the ground and the output comes off this side, correct? Plugs into our battery. Now, we can control this, right?
Yes, this equipment has an app that you can actually tells the equipment the exact amount of amperage that you need to supply to the equipment that you're gonna...
Okay, because this one here is input is 9 to 35 volts. This aircraft is 14 volts, but it could be a 24 volt aircraft or whatever. So our input is fine here. And then we can control, well, how much output do we want? The output, number one, is only gonna output what it's getting. We can tell it that we only want you to output 12 amps because we have the whole load issue that we talked about. We've got a 40 amp alternator, the panel's taking up 12 amps, we have to calculate. So we can set this in the app and say, you're only allowed to use 12 amps, 14 amps, whatever it is we decide, so that we don't use up our overhead from the alternator, correct?
Yes, and this is a security control. Keep those amps and levels, voltage steady for your battery charge.
Okay, so from a safety standpoint, what we have in this aircraft is normally you would go from the bus to a breaker to a switch, then the switch to here. But in this aircraft, we're using a breaker switch. So we don't have a dedicated breaker and a dedicated switch. So we're doing breaker switch, then we come to here. Then we can control everything here, tell it how much amperage it can send out. And from here, it's going into our lithium battery. And then this has its own BMS built into it too. So we have safety features built in here, safety features built in here, safety features built in the panel and breakers. So I feel really comfortable that the way that we designed this is pretty safe. Got a whole bunch of line of defense here. Why they say this isn't lithium ion, this is a big deal. I know that a lot of people freak out about lithium ion and they're gonna have a meltdown in an airplane, and you know, as you hear the airlines freak out about it, you can't pack it. You know, there's all that kind of stigma about lithium ion. First of all, it's gotten a lot better. I'm not saying there's not dangers, but this is the first consumer unit that is called lithium manganese cobalt. Go look that up. It's a very different technology. First of all, this is 40% lighter than lithium ion. It's much more denser in the cells. There's nowhere near as much fluid and water that's in these. Much safer. So, you know, if you had a lithium ion battery here and you screwed a screw through here, you're gonna get a thermal meltdown. You're gonna get a problem. You're probably gonna have a fire. This, because there's not a lot of liquid and because of how it's dense in material, you can screw through this, you're not gonna have a meltdown, and the BMS is gonna control it and stuff. So much, much safer, which is one of the reasons that we finally decided to do an all electric camping build, is because we now feel safe that we can have lithium in the aircraft and be safe. So anything else you can tell me kind of about our build and things we should be worried about, or maybe things we didn't think about?
No, I think your designs make sense, because the most important thing, like you said at the beginning, is the safety issue is the most important thing for aircraft, and avoid to get fire into the aircraft. Nobody wants that. Yeah, it looks like an interesting design. Congratulations for the design. So very impressed.
My mission is very specific. You got to know what your mission is. I am certainly not advocating, folks, you get a 2,000 watt Jackery lithium ion battery and throw it in your King Air and go flying around. I'm certainly not saying that. My mission is I'm never more than 1,000 feet off the ground. I'm flying an aircraft that if I have a problem, I can land in somebody's front yard in a matter of, I can land right out here in the taxiway in a matter of about 15, 20 seconds, because I'm 700 feet, 1,000 feet. So my mission's very different. So my mindset and how I'm doing things is very different as well. You got to know your mission. If you're in a Bonanza and you're flying at 9,000 feet, you might not be able to get down fast. Now you have to start thinking, well, if me as a pilot, I do want to take that risk with lithium ion, here are some things you can do to be safer. Maybe small battery packs or something like this, and it's a lithium charger or something like that. Make sure the contacts are covered. It's in a case, or put, you know, tape on it, and it's not in a pile of wires or other stuff, because that's where you have issues, where stuff grounds out, and that's where you can have an issue where you get a meltdown. The other thing with lithium ion, and you're all going to say, well, that's crazy, is if it is only charged at less than 50%, it's way safer flying with lithium ion. They get much more dangerous, lithium ion batteries, when you're flying with them at 100%. Now you might be saying, well, I always charge my iPads and my phones. I get it in those, but I'm starting to talk with something that's larger like these. I know a lot of people will fly with charger, lithium ion charger packs. They're pretty big and stuff like that. The reality is if they're only 50% or less charged, they're way, way safer. Go look it up, go do your own research on this. Don't just take my word for it, and then just make it sure it's stored in a safe way. The other things you can do, if it's something that you really want to go to that level, there's cases you can get out there to store lithium ion. Like if you really have to travel with them, maybe you're a videographer or maybe whatever, you got like Zargus makes the aluminum cases, and in the aluminum cases they have special packs that you can put in there that you can store your lithium batteries. So if you're putting a lot of lithium batteries in the back of your King Air or in your Citation or something, there are safe ways that you can actually travel with lithium ion. But the reality is hopefully more and more, this technology is going to become available. It's certainly a little more expensive than lithium ion. This company is called Yoshino. They're the only one and the first one in the United States that actually has solid state lithium batteries now. So this is going to be a game changer the more and more of these come online, but hopefully we at least shared a little bit with you on some things you can do to be safer when flying with lithium batteries. One last thing I want to talk about, because this is a camping aircraft where I'm going to go land this thing in the mountains in Georgia or Idaho, and I have to charge this thing. So we have options. We can actually hook up solar panels to this to charge everything that's coming off it, or we can hook up solar panels directly to this unit. So in our camping build, we're actually going to have two, which are only 6 pounds. with Yoshino has solar panels that are 6 pounds and they're 25% efficiency. Now, that's actually a lot. People are like, only 25%? Well, that's actually pretty efficient because most of the industry is like 20 or less. If you get some cheap stuff off Amazon or something, you hardly ever get into the mid 20s or more. So you can connect your solar panels to this. We're going to have 2 in the aircraft, which are 2 200-watt solar panels that'll charge this in like 4 or 5 hours. That then I go all night, and usually that's charging, if it's 0, charging it to 80%, 4 or 5 hours. I'll probably never get this to 0, so you can get this charged. Good points. This was great. And Jorge, I just want to thank you very much for helping us kind of just do some basic information for people to give them a little bit more information about the aircraft.
Anytime.
And of course, guys, Banyan Air Service, they're a huge support to us and everything we do here. So make sure you go check out BanyanAirService.com, and we will see you guys in the next one. Take care.